Given the equation of a curve, y equals 2 square root of 3x plus 4 minus x. We need to find the equation of the normal to the curve at the point 4, 4. Your answer should be reported in the form y equals mx plus c. To find the equation of the normal, we need to find the slope of the normal, but we can find the slope of the tangent first, which is dy dx. So you have to write the equation of the curve in the form 2, 3x plus 4 to the 1/2 minus x, and we differentiate this. We have 2 here, bring the exponent down, which is 1/2, 3x plus 4. The exponent is reduced by 1. We have negative 1/2. Differentiate the inner function, that is a 3 minus 1. So that dy dx is 3 times 3x plus 4 to the negative 1/2 minus 1. And we can write this as 3 over square root of 3x plus 4 minus 1. We find the slope of the tangent line first, dy dx when x is 4. That will give us 3 over square root of, when x is replaced with 4, we have 12 plus 4, which is 16 minus 1. So 3 over 4 minus 1, and dy dx is negative 1 over 4. The slope of the normal line that we want is the negative reciprocal of this. We have negative 1 over 4. That will give us a value of 4. Then the equation of the normal. We have y minus 4 equals 4x minus 4. So that y minus 4 is 4x minus 16. And that can be written as y equals 4x minus 12. Part B, we need to find the coordinates of the stationary point. At any stationary point, dy dx is always 0. So we set dy dx to 0, and we use this part here. This is dy dx. We set that to 0. 3 over square root of 3x plus 4 minus 1 equals 0. Rearranging 3 over square root of 3x plus 4 equals 1. Cross multiplying, we have square root of 3x plus 4 equals 3. Squaring throughout, 3x plus 4 is 9. And solving for x, we have x equals 5 over 3. We need to find the coordinates of the stationary point. So we need to find the y coordinates of the function. We use the original equation. Then y is 2 square roots of 3 times 5 over 3 plus 4 minus 5 over 3. And we have 2 square root of that is a 9 minus 5 over 3. So that will give us 6 minus 5 over 3, which is 13 over 3. Then the coordinates of the stationary point is 5 over 3 and 13 over 3. That will give us the coordinates of the stationary point. Part C, determine the nature of the stationary point. So we want to know whether the stationary point is a maxima, a minima, or something else. We can either use the first derivative test or the second derivative test for part C. For the second derivative test, we will have to differentiate this again. Yeah, we can always use the first derivative test. We look at the sign of dy dx. So looking at the sign of dy dx, we form a sign diagram here. This is 5/3. To the left of 5/3, we want to know whether dy dx is positive or negative. You can pick a value, say x equals 0, and substitute into dy dx. So when x is 0, you have 3/√4. So that is 3/2 minus 1, and that is certainly positive. And to the right here, you can pick a value of x. So you can pick a value that is greater. For example, maybe 10/3, and substitute here into dy dx. You see that you get a negative value. You have a positive slope and a negative slope. So this forms a curve with a maximum point. We say that the stationary point with coordinates 5/3 and 13/3 is a maximum. Part D, we need to find the exact area of the region bounded by the curve, the x-axis, and the lines x equals 1 and x equals 4. From x equals 0 to x equals 4, the curve is above the x-axis. Then, to find the area, we just integrate the equation of the curve with respect to x from 0 to 4. Then we have 3x plus 4 to the 1/2 minus x. And we integrate this with respect to x. Upon integration, we have 3x plus 4, increase the exponent by 1. So we have 3/2 divided by 3/2 times the coefficient of x, which is 3, minus 1/2x squared, which we evaluate from 0 to 4. And this part here is 9/2, so that will give us 4/9. Then we have 3x plus 4 to the 3/2 minus 1/2x squared from 0 to 4. We replace x with 4 into this whole part. We have 4/9. Then when x is 4, that will give us 12 plus 4 will be 16. So we have 16 to the 3/2 minus 1/2 times 16 here. Minus, now this expression is now evaluated with x equals 0. So we have 4 to the 3/2 minus 0. That will give us 4 to the 3, that is 4/9. So that will give us 64 minus 8 minus 4/9. 2 to the 3 is an 8. So we evaluate this expression and we get 152/9.